Hello, welcome back to Microeconomics with me, Professor Lewinsky. We're continuing here in our discussion of the theory of the firm and perfect competition. What we're going to talk about today is thinking through cost curves. We just finished thinking about production and different types of cost. Now we're going to introduce the ones that we're going to use the most in analyzing firm behavior. So here is a table where we are looking at production. In this example, we're looking at water bottles, and we have the number of workers per day and the number of bottles per day. So this relates workers to production. And what we're going to be doing here is thinking about cost. Right? So our fixed cost, those are not varying by output, but our variable cost is coming from the number of workers, and that is going to vary with output. And then our total cost is simply the sum of fixed and variable. Marginal cost is the increase per bottle. So this is actually technically average marginal cost in our total cost. So moving from 0 to 80 bottles, our total cost went up by 12. 12 over 80 is 0.15. So this is our marginal cost. The three main cost curves that we're going to talk about in this course are the marginal cost curve, the average total cost curve, and the average variable cost curve. And you can see here is our marginal cost curve per worker. I'm just showing the first three units, 40, 52, 64, and sorry, that's our total cost. Our average total cost curve and our variable cost curve. Right? And we want these in average per units. The other thing I'll emphasize in this graph is that you can see it looks like this marginal cost curve is crossing each of these at their minimum. I want to emphasize that this is something that didn't just happen to come to be. When we're thinking about marginals and averages, so averages, you can think about kind of like past info about quantity that's already being made or things that have happened. Averages always move towards marginals, new info. For example, let's say your GPA for your first 2 years in college is 3.8. What would happen to your GPA if you got a 3.9 this semester? So your past average, your past performance, your GPA is that 3.8, right? And your current, the marginal, is the this semester 3.9. And I hope that in looking at the example, you realize that the 3.9 is going to be pulling your GPA up, right? Illustrating that averages are moving towards marginals. So what would happen if your GPA was 3.7? Or your for your most recent semester? That would be pulling your GPA down. Averages would be moving towards marginals. With continuous functions, the average actually will cross the marginal at the max or min. Right? So here's a graphical example. I'm leaving some stuff out. How did the average get up here? We're skipping over that. Right? But what we have is that the average is moving down towards the marginal. Right? Moving towards the marginal, moving towards the marginal. And this being a continuous function, at some point, unless the marginal is continually racing away from the average without bound, they're going to cross. Now, once they have crossed, we can see that the marginal is now above the average. Right? You worked really hard, your GPA was pulling your semester GPA kept pulling it down, right? And now you kind of are doing better, and your GPA is now getting pulled up by your performance this semester. Right? Pulled up higher. Right? The average is chasing the marginal here. And what is going to happen is that this point of intersection here, of these continuous function is the minimum of the average, right? That point where you finally moved your marginal above your average is as low as you got, right? All of these things, your average was moving down, and now above it, it's moving up. With the continuous functions, and we'll be treating quantity as a continuous function, so you could make 1, you could make 2, or you could make 100, or 1.75321, or pi, right, a continuous function. Both our average total cost functions and average variable cost functions are going to have this behavior. And the key idea here is that the marginal cost curve is going to cross the average total cost curve at the minimum of the average total cost curve. Now let's look at how these cost curves help us to think about profit maximization. So what we have here is still our marginal cost curve, and we have our average total cost curve in this darker blue and average variable cost in purple. So let's now say that we have the market price of 20 cents per bottle, and think about what it would take to maximize profit in this instance. To maximize profit, we look at the marginal revenue from each bottle sold, and that marginal revenue is just the price. Right? The total revenue is price times quantity. So the extra revenue we get from each bottle sold is the price, that 20 cents. And in order to maximize profit, we continue doing the activity selling and making and selling these bottles as long as that marginal revenue is greater than marginal cost. Right? We keep doing it right up to that point. Because this is extra revenue we're getting over the marginal cost for each additional unit. So if the marginal cost is less than the price, if you are any of these quantities down here where marginal cost is less than the price, you need to increase that quantity because marginal cost is an increasing function. If the marginal cost is greater than the price, if we're to the right of this quantity, we need to decrease the quantity because the cost here to produce those bottles is higher than their price. And so that leads us to the rule that we're maximizing where marginal cost equals marginal benefit or marginal revenue, and marginal revenue is price. So in order to maximize, we need to find that point where price equals marginal cost. So our profit here, so now we've found where our profit is maximized. Now let's talk about what our actual profit is. So profit is always going to be total revenue minus total cost. So the total revenue is price times quantity. That's this green area here because this is quantity and price is 0.2. So we can actually see it graphically. This is total revenue. Total cost, we can do this many different ways, looking at functions, looking at our total cost function, but the easiest way in terms of thinking about this graphically is if we take average total cost at that point, right here, at this quantity. That's average total cost when we're at 260. And if we take an average and multiply it by quantity, we get the total back. Right? So average total cost times quantity is total cost, this whole area here. So graphically, our profit is going to be this area up here, like this blue rectangle. Right? And we can see that it's a positive profit because price is greater than average total cost. And in fact, our profit is going to be the difference between price and average total cost times quantity. Right? So it's this area of our rectangle with this height of 20 minus 12 cents. That's our profit per unit. that is the height of our rectangle, and the width is the quantity, or 260. So in this example, the area is this 8-cent difference times the 260 units, and that's $20.80 per day. Now, when we're thinking about profit maximization, we're thinking about finding that quantity. But when we're thinking about the short run, we can't change fixed cost. Fixed cost is fixed. It doesn't change with output. Therefore, that short run profit maximizing quantity, it doesn't depend at all on fixed cost. Right? We're only looking at the margins, marginal benefit, which is marginal revenue, versus marginal cost. This is our cost benefit principle. Is that extra revenue, is the price worth foregoing that extra marginal cost? So we're going to choose that point where marginal cost equals price. And as we have seen, marginal cost rises due to those diminishing returns as production increases. The other thing to note is that it's possible that the best you can do, the maximum that quote-unquote profit that you can have, is actually a loss. So with a much lower price in this example, where you maximize at this Q star where price equals MC, however, we're going to have a loss here because average total cost is greater than price. The formula still applies here. It's price minus average total cost, but it's going to be a negative profit because average total cost is greater than price. So one other note here. Supply, if you recall, is the relationship between price and quantity supplied. What we just established was that in perfect competition, when you're maximizing profit, you pick the quantity such that price, which is marginal revenue, they're equal in perfect competition, equals marginal cost. So we're finding this point where price equals marginal cost. That maximizes the profit. In other words, what we're doing here is mapping a price to a quantity. Price, quantity. We did a higher price, higher quantity. And that's actually the definition of supply, mapping a price to a quantity supplied. So the marginal cost curve is the firm's supply curve. There is one caveat. It might not be worth it to produce at all. We'll talk about that in more depth in our next video. But just to preview it, if you're not even making enough, if the price is so low that you're not covering your variable costs, then it's not even worth it to produce right now. Just shut down and be done with it. So in general, though, the marginal cost curve is the supply curve. So those are the cost curves that I wanted to discuss today. What we'll be doing in our next video is thinking about longer run adjustments, in particular entry and exit, and how those dynamics look, how those impact the market, and how the market impacts the firm and impacts those different indicators. So thank you for joining me. Hope you have a great day. Leave comments if you have questions, or send me an email, and take good care.